Welcome to another CO2 Monday in the Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and this week I have a returning guest, a really good friend of mine, Andre Patnode from Copeland, a global CO2 expert. You know all about him. You heard about his stories, but today we're going to be diving into a topic that we didn't really cover yet, and I know we could talk days and days on this topic: transitioning to CO2 architecture, transitioning into CO2, because we know this is the direction we're going with regulations. And the further we go down the timeline as it continues to go, we're going to be moving more and more to more natural refrigerants and low GWP refrigerants. And we're seeing a huge uptake here in North America as well as globally for CO2 architecture. And there's so much to it. It's not like just say, oh, we're going to go to CO2. There's a lot of considerations that we need to think about. And depending on where you're at here in Canada, we could still use HFCs realistically, or low GWP blends like HFC, HFO, because it's still 2200 GWP and below for centralized systems, rack systems, which is going to change besides Quebec, but we'll see that change over time. But we are seeing the transition even here to CO2 in Canada, and I'm excited about this conversation. Andre, welcome to Refrigeration Mentor Podcast. How you doing?
Hey, I'm doing great, Trevor. Thanks for having me. I really appreciate it.
Well, I always love
Looking
having
forward to
you.
it.
We always have great conversation. It's the conversations we have not on the podcast that are awesome. I'm like, we should be recording this right now because this is good stuff. This is really good stuff
Yeah,
that people need to hear.
actually, you still owe me to send me those the recordings we did last time to make sure I can review them.
Yeah. No, I haven't even got to them yet. We do so many together, but I will get
Yeah,
you
it's
those.
great.
So we're going to be diving into the transitioning to CO2 architecture. But before we get to that, I know a few weeks ago you were down in St. Louis at the NASRC event, and we were at
Yep,
the one in Irwindale earlier this year, and you were at this one. Let's talk about
yep,
that a little bit because I'm going to have Morgan and
sure.
Daniel talk about it in a couple of weeks. They're going to be on the show, but
Great.
how was it? Tell me about what went on there.
It was awesome again, Trevor. I tell you, there to me when I go to this type of event, it's an event that NERCC does a great job of bringing the industry together in
Yeah.
kind of a non-threatening way, if you will. It's all about education, and they do manage to pull all the manufacturers, parts suppliers in one area. And this facility was a union hall in Earth in St. Louis area, and a beautiful facility. So we had, I don't know, about 50 suppliers, about 35 end users, and almost 400 contractors and apprentice, mechanics and apprentice.
Wow.
And just like Arendelle, Trevor, you're getting ready to present a class, and like 20 minutes before, these guys are sitting in their chair waiting to make sure that they have a seat. And no matter what class you went to, they were full. Maybe except for the last class of the day, well, they're half full still. But it was incredible. Great content, great feedback. And yeah, looking forward to Pittsburgh in March and back to Arendelle, California in April of 24.
Yeah, no, I'm pretty excited about what they're doing. Like I love what Daniel, Morgan, and Gene are doing. And like you said,
Yep.
bringing industry together. There's all the top manufacturers there, all the top
Yep.
contractors go there. They're traveling from all over the place, sending their technicians,
Yep.
which is great. And it's
Right.
just like an industry. We need to do more of this stuff. Yes, there's a lot of competition out there, which is great, but we need to also come together to grow our industry because our industry is starting to, it grows, but the people within it are shrinking. We got less and less people coming in. So we need to work together to get more people to come in, to love refrigeration like us
Yep.
and grow in it.
No, you're right. That's what's kind of neat about this event is you talk to people from California, from southeastern United States, near St. Louis, but they came from all over the place. Which to me, a contractor investing that much, not only to pull his tech off the road, and he's not getting billable hours while he's sitting in a training for 2-3 days. It's a huge investment and a testament of the value of, I think, what they received. So it was good.
Yeah, I love it. I'm excited for the other ones that come up. And this is a good thing. These are the events you need to start hitting this stuff. You need to, if you're out
Yep.
there, you're a technician, you got to learn about where they're at. They put them out a few months in advance, or even I'm sure they're going to get more time, give you more time. Like the one in Pittsburgh's in March, so you still got 3 months,
Yep.
4 months to plan. The one in Irwindale in California is in like 6, 7 months, so you can plan to do this. Talk to your manager, your supervisor, whoever, and see if you can get out there. It is an investment. It does cost money, but the value that you get out of it, the people you meet, like you're not going to get this anywhere else. You're not going to get that anywhere else. So
No, no, you're right. And I push, for example, to have some of our CO2 techs that work in the lab in Sydney, for example. Hey, send them there. So we had a few of them there as well, which is great because it was rich content,
yeah.
for sure.
Oh, it is. Every time I look at the list, it's just awesome people there. All the top trainers, experts are there sharing their knowledge, and not only from the manufacturers, like I said, you get the top end users using CO2 there that are sharing their knowledge. You get the top contractors and technicians there sharing their knowledge, and that's what it is. We got to uplift each of one of us. We got to all get better to help this transition that we're going to talk about today. The things that we need to consider when we're transitioning into refrigerants like CO2. So a good segue.
Right. No,
So
it's great.
let's start off. Like we know, we've talked about it before. The transition has been happening, low GWP, phase out of high GWP refrigerants. We're seeing different things like PFAs and TFAs they're talking about in Europe, for F-gas. But we know that it has been happening. The biggest retailers in the world are starting to say, we're going to go CO2. If it's transcritical CO2, subcritical CO2, secondary, whatever. But we know they're starting to make that move. And a lot of them said it in public that we're moving that direction. What are some of the key things we should start off with that they need to consider before making this choice?
Yeah, that's a great question because in conversation we're having more and more with these retailers, they know they have to do something, right? They have to decarbonize. They have to, if you're in California, you've got targets you have to meet by 2026, and then GWP reduction targets by 2030. So they know they have to. So the thing they really need to ask themselves if they want to go to CO2 is, okay, where exactly is this store located that I'm thinking of? Or these several stores? And how does the climate impact that technology? Because we do know that CO2 in its base form, basic system architecture, is quite efficient in a low ambient area. Canada, for example, when most of Canada, 90% of your hours of operation, you're below 60 Fahrenheit. Okay, that other 10%, depending on hey?
Don't say that, man. Don't say that.
I know winter's
We're coming into winter.
But that's a consideration, right? And so where is it located? And take a look at the ambient temperatures, and not only ambient temperature, but also humidity, because we found out that humidity can play to your advantage with a CO2 system, with any system really, because you have the wet bulb effect that helps reduce your condensing temperatures and keeps you as low a pressure as possible. So those are things that we think are super important, that the weather, how it impacts, but also the technician skill in the area. You mentioned it a while ago. And as I was preparing for this webinar, this podcast, excuse me, I'm thinking about as CO2 continues to ramp up, we need the service techs to be able to satisfy that demand. But we're a little bit challenged right now in getting service techs into the refrigeration field and staying there. So retailers also are thinking about and are telling us that when they think about a decision to put a CO2 store in the region, can I find service technicians that have CO2 experience in that area? Because their fear is if they don't, the learning curve may cost them maintenance dollars, high service bills, loss of CO2 for inadvertent loss of, through a pressure relief valve. And that just adds to your total cost. So those are two main drivers from, installing a CO2 to start with.
Yeah, I think that though is going to change. Like right now, yes, we're at that point. But at some point, the technicians in schools it's going to be CO2 in the schools. I'm working with schools and I'm pushing real hard globally to try to help schools around the world. It's entrenched because you need to learn about low GWP. There are a lot of the schools out there are still learning 404 or 22, but I know in 10 years, this conversation is not going to be an issue because the new people coming
No.
in are going to be learning on these technologies. So it
Right.
is this transition point, I believe, that
Yeah.
down the road it's kind of like in the 90s when you're doing that transition to R12, the 404 or whatever, in the 80s, whatever those transitions were, right?
Sure.
This one's just
Sure.
a little bit more drastic because there's just more controls and there's more complexity to it. But I think the
Yeah.
newer techs coming in, they're going to learn from scratch that stuff. And I don't think that's going to be a problem because I see this kind of in Europe, in certain areas in Europe.
Yeah.
Those guys that are coming through, they have that. They're starting with CO2. It's not like they're starting with HFC and then they got to learn the next thing and the next thing.
Right.
They're starting
Right.
right out there. But it is a concern
No,
right now.
right now it is a concern because that's the feedback we're getting from our customers, because we sit in front of a lot of end users on a weekly basis and talk about low GWP, talk about CO2, talk about other options, R290 and even A2L options, and all of these things kind of bubble up in their mind because they're there to sell groceries and keep their costs as low as possible. I'm talking grocery retailers. I know it's not the only customer. Those are things to think about. And the other thing as well is thinking about an area. What do I need to do? What kind of complexity adders do I need to add to my CO2 system in order to mitigate the ambient requirements of that specific zone or region?
I think that's key too, because there's a lot to it. And going from a new store, it's easy, I would say. Like if they're going to CO2, it's quite easy. But when we talk about retrofits, there's going to be a different conversation there as well.
Right.
Because if all
Right.
of a sudden they don't have the right power coming into the building and the CO2 system is going to need bigger distribution. I know
Yep.
most of the retailer I talk to, they're worried about disruption. It's not even about the
Yep.
technicians. It's not about the equipment. They're worried about, I don't want my store shut down for 4 weeks or even a week. You know what I mean? So
when you're doing a retrofit, that you're absolutely right. And I've seen some retrofits go on for very long periods of time. This is years ago. I mean, they've gotten much better at planning and retrofitting on the go, but it is disruptive. There's no doubt about it. But yeah, no, that is one thing. And the retrofit remodel is a different conversation. And we're starting to see customers develop a strategy now that if they have a lineup of cases that have reached end of life, then instead of ripping and replacing everything at once and having a full store disruption, they're thinking about doing lineups now and having distributed CO2 equipment. So you've got some low temp loads, some medium temp loads, and get that done, get it finished. And then maybe a little while later on, look at adding another piece of distributed CO2 equipment again to try to keep that disruption as low as possible. But you've got a strategy to transition over time to a full natural solution. Plus, when you do that, you're optimizing your suction pressures. So you've got an energy efficiency play there as well. If you can loop as many of the same suction pressures together, then you've got an energy advantage.
So, and this is something that's important though, because what we've talked about it before, we really need to see more of the end users talking with the manufacturers as well as having a contractor in that conversation, because I think that's really important as well, where I see a lot of times they're not in that conversation and they're working on the equipment day in, day out. Maybe they're new to CO2, but they know refrigeration. And when they're in the conversation, I see the projects rolling out a lot better because everyone knows what's to be expected. And I think there's some unrealistic expectations for CO2 startups, CO2 commissionings, and even the fine tuning. There is more to it. There's more electronics, there's more case controllers, and it does take time, and it's going to cost more money right now. But going down the road is going to get quicker over time, but not like it is for HFCs or the way we did it for 50, 60 years. We had all that time to refine it, make it better. You know what I mean? Where we're just newly in the CO2 world. So I love that. So let's get into kind of segue into like the total cost of ownership now. So we know that they're going to be moving into CO2 and some of the things they got to think about. Do they have technicians working there? What's the ambient, where am I actually located with my thing? But what now, let's get into that total cost of ownership and what they should be thinking about.
Well, when we did a total cost of ownership study a couple of years ago, And we looked at basically comparing a CO2 system. They want a lot of retailers that maybe haven't, are just in that trial phase, want to understand when they look at natural solutions is how does it compare to an HFC centralized 448 rack, for example, right? And so we looked at that. We actually had a consulting engineering firm design us 8 different stores from scratch. And CO2 was one of them with a basic system, one with adiabatic, comparing it to a centralized. And some of the things, of course, we looked at different areas that you mentioned from a weather perspective. How does that impact it? The number of compressors, whether you're using an adiabatic gas cooler or a dry gas cooler, how does that impact your peak energy? Because we looked at annualized energy, and then we also want to look at peak energy, because I think many of us know when CO2 is operating supercritically above this critical point of 87.8 degrees, your energy kind of boosts up a bit. And during the hot summer months, you may pay a peak demand charge in that area. So that's a consideration that when you look at total cost of ownership, how does that play into it? Number one. So you're looking at CapEx, you're looking at maintenance over the life from a total cost of ownership. And then we looked at CapEx, maintenance, and of course, energy. And it's interesting when you look from region to region, how energy can have a big influence on your 20-year total cost of ownership. And not just that, when you compare CO2 to other technologies, we looked at condensing units, we looked at R290 micro distributed with water cooled, and we looked at a few other systems. CO2 fared out pretty good overall, especially with adiabatic when you can mitigate that peak. So,
question for you.
Those are the main buckets that we looked at anyway.
I have a question for you. So I've been hearing, we've been talking about adiabatic for years, and we see it and it's happening. And I do trainings on almost every manufacturer around the globe now. I'm training on all these different manufacturers. And what I'm not seeing, especially in North America, as much of is parallel compression. Yeah. Like, why haven't we, I don't know, why aren't the manufacturers, and maybe there's reasons, and I need to talk to more of the manufacturers about it, but why aren't we seeing more parallel compression in North America at this point?
I think we will. I think we will, Trevor.
Yeah, I know we will. I know we will.
It's an added complexity that I think many end users were waiting to get, a feel-good feeling from their manufacturers, from their suppliers, that we can manage these systems in a parallel compression, which is parallel compression at the end of the day is another suction group, isn't it? And if I can share a chart here, the reason that I think we're going to see more of that, let me see, share.
Because really with parallel compression, when you have all that in the middle of the summer, when you have all that flash gas coming out of that fluid, you get more gas coming out of the fluid into your receiver, your flash tank. Instead of just putting it into your medium temp suction, you actually have another suction at a higher pressure, suction pressure, which reduces that pressure ratio or compression ratio, where now you can save energy on the system.
So if we take a look at this central image here, Trevor, before I get to the chart, is what you're talking about here is this parallel compressor is really is being fed by excessive flash gas at a suction pressure that's typically 100 TSI higher than my medium temp suction. So really, that compressor has more compressor capacity now because the suction is higher. That's one thing. Its compression ratio has just been lowered. So that's a good thing because you have a lower total heat of rejection going into the gas cooler. And then the energy is less because the compression ratios are less. And then the OEMs look at it and say, okay, well, I could downsize this compressor, my parallel compressor, to give me the same capacity as these medium temp compressors because I'm operating at 100 PSI higher. So those are the net advantages of wanting a parallel compressor digesting that excessive flash gas from the flash tank in the summer. What we found from our climate study was this chart here. What this chart is showing that if when we compare in 13 climate zones, looking at 166 cities throughout the US, the ones with the blue boxes at the bottom, these are dry climate zones. Even though it might be cold, it's dry climate zones. And you can see when you compare adiabatic, which is the hatched blue, that hot, dry 3B here on the left saves 14% annualized energy savings versus a basic booster system. But parallel compression in a dry gas cooler gives me 8. So obviously adiabatic's better here. It's better in cold 5B. It's better in mixed 4B, dry B, excuse me, and cold 6B. However, it's better annualized 4 out of 13 climate zones. So the flip side is there's 9 climate zones that see an energy advantage using parallel compression annualized versus adiabatic, which reinforces the point you just said, right?
Yeah.
You're going to start seeing more of parallel compression happening shortly.
But this
year, and we're seeing that.
This is where it comes back to what you said earlier, like understanding where you're at with that equipment. Like, are you in a warm climate, cold climate? Are you in humid climate, non-humid climate? And this is why you need to understand this as a contractor, as an end user, and even as a manufacturer. You need to understand all this different stuff, because it's not plug and play. You can't just take a condenser like we used to do and just throw it in an area and just reject all the heat out. We get energy stuff. We need to look at the energy, the cost of energy, where before we're just throwing it out to the atmosphere, all that heat that we're now reusing in these applications, right? We're being smarter about refrigeration than we were in the past, because it wasn't something we didn't think of. We didn't think about the energy.
You're right. We're being smarter about refrigeration. You're absolutely right. And you talked about heat reclaim. It's another part of that total cost of ownership. It's another part of decarbonization, because a lot of these retailers, especially the large ones that are publicly traded companies, they have ESG goals. They've got carbon emission reduction goals. And now they're looking at, oh my God, I got to get out of fossil fuel at some point. I've got this refrigerant using CO2 already for refrigeration. It provides a tremendous amount of heat. How do I leverage that heat for my hot water? How do I leverage that heat for my space heating? How do I leverage the heat for maybe dehumidification during shoulders, seasons? So a lot of that is, you're right, is being smarter about the energy in a system. I mean, I remember dealing with Ben, our buddy Ben in Oxford there years ago. And one thing that always stayed in my mind talking to Ben was every time he'd go into a space years ago, he'd look for all of those opportunities where energy has been kind of wasted on refrigeration, and how can we repurpose it elsewhere? And that's what we're starting to see a lot more in the supermarket space. As a matter of fact, we're also involved in a study with a consulting engineering firm studying exactly that. So what is the energy implication of direct air for heat reclaim space heating versus water source heat pump, for example? And what are the impact of driving my head pressure up to heat? And understanding those dollars and cents is going to be key to reporting out to, providing the industry with more valuable information to make right decisions.
And I love that, because I do lots of trainings with a lot of different people, and technicians, manufacturers, engineering firms. And there's all sides of the stories. Oh, heat recovery is no good, because you got to drive up your head pressure to get some heat, when you could be doing low condensing and you're dropping your pressure, and vice versa. So there's all these things that are, oh, Trevor, I got this end user, they turned off their heat reclaim because it cost them more money. Well, does it? Right. Maybe it wasn't designed properly. What were they trying to do with it? Because there's so many in HFC. I've done so many supermarket trainings where technicians said our heat reclaim's turned off. It's been turned off for years, and nobody knows how to work on it. Well, maybe that's why it's turned off, because nobody knows how to work on it properly. But There's always two sides of the stories. You just want to understand the
Right,
full picture before you make that
right,
decision.
right. Maybe they had a leak and they never topped it off. Now they don't have enough refrigerant.
Yeah. Well, we've definitely seen that, right? Definitely seen a
Right.
lot of that. So it's going to be important to get into some of this stuff, like with your customer. If you're a technician or a contractor out there, technicians, why this is important. And I know you're listening on here, you're driving, it's like, why is this stuff important to me? I'm out there fixing equipment. It should be important for you because you're going to be working on this stuff and getting to understand why your customer made a decision to go with adiabatic versus parallel versus ejectors
Right.
when we start to see more of it. And our job is going to be helping educate those end users as well. Because
Right.
yes, the corporation or the larger company is going to make a decision. That manager might not understand it as much, and it's going to be
Right.
our responsibility to explain to them in terms that they understand why they went this direction and how you're going to help serve them and bring them value to get their system running normally and properly.
No, I totally agree. Now the large companies that have engineering firms and all that, they work with the consulting firms directly. They understand the specifications. They decide what systems they want. But the independent grocers rely a lot on that service tech that comes in their store and asks for their advice all the time. And there's a lot of independent grocers, like 21,000 locations in the US alone. So that's a lot. So it just kind of reinforces what you just said about why it is important for that individual, that service technician to kind of get a little bit more informed. So when he's asked about those decisions, you've got some information that you can provide. And if you don't know it all, at least you can reach out to someone to get more information, right?
Yeah, no, and that's exactly right. It's just the more knowledge you have, the more informed you are, it's the easier you can help your customer out. And it's going to take time. Like this is
Right.
new. Andre's been doing this for almost 15 to 14 years, learning CO2. I'm almost 7 or 8. I learned from Andre a lot of my stuff. And the way it's continuing on is that we got this, okay, we get the story in there, we design on the architecture, but that's not it. Then there's install, then there's service, and then there's maintenance. This is something that's very key as well to understand for a total cost of ownership. And I know you mentioned it once before, but what are some of the highlights in that installation, in that startup that you're seeing? Because you've been involved in a lot of this and you're working with the end users, you're working with the manufacturers, well, and the
Right.
contractors. What are some of the things that you're seeing for those installations and startups?
And you've mentioned this before, Trevor. The thing about the startup is being extra anal, if you will,
Yeah.
about making sure that all the connections are right, making sure that you've got continuity, making sure that the transducer plugs are in right, they're going to the right areas. You're double checking to make sure everything is properly set up before you start the system, because the last thing you want is a pressure transducer that's reading suction instead of discharge, or
Yeah.
vice versa, right? Or temperature sensors that are just kind of hanging off a pipe. That's a critical gas cooler out temperature sensor that's managing a lot of that systems, that nervous system of that booster. So all of those things right off the bat are super critical before you even charge the system. But when you do start it up, what we're finding out is that, and you mentioned it before, is that training at that startup and commissioning is absolutely critical, because if it's not done right, if it's not set up right, you're going to have a system that's just modulating like crazy, because we already know that CO2 is extremely dynamic. It's very reactive to pressure and temperature changes. So setting it up right the first time is key. It'll prevent pressure relief blow-offs. It'll prevent proper issues, oil issues. And in some cases, we've been called in many times to try to resolve those startup issues, because and train the individual so that next time they know exactly how to set up the high pressure control, for example, and make sure that high pressure control, compressor cycling, fan cycling is all integrated properly. Because if you can calm that flash tank down, the whole system calms down.
Yeah.
So it's that initial setup is key for
Yeah.
sure.
And like this is what Refrigeration Mentor does day in, day out, CO2 training with people around the world. And one of the biggest things that
Mhm.
I see, and I've been learning from technicians who installed hundreds of stores and worked on them all the time, they say, Trevor, when we get the
Right.
store set up right and then we fine tune it, we never have a problem with it. But the stores that we don't get set up properly from day one, we start
Mhm.
running into issues, and then other people go in and start playing around with stuff, just trying to fix it. Not that they're trying to break it or anything, they just maybe
Yep.
not know. And they think, hey, it's already been set up properly. I shouldn't mess around with this, or I got to start messing around with it. And that's where the stores take months and months and months to get back into rhythm. And
Right.
but most of the CO2 stores and the trainings that I do, the guys say after we set it up right, I never had a call this year in the store. So
Yeah.
some of the guys, they got a few stores that I'm training in their area, and they're like, we never get calls there. So it's one thing that
That's
uh,
great.
they need to understand. They can purr like a kitten. What do you think about fine
Exactly.
tuning now? This is something that has been in the past, and end users were like, well, we don't need to recommission the store. We don't need to go back and do, that preventive maintenance was like, oh, well, that's operational costs. Let's not really talk about it. And I know when I was at Copeland with you, you did a bunch of
Yeah.
white papers on the 20-year studies on stores that were 20 years old and going in to recommission,
Yep.
refine tune, I guess, and adding stuff. I remember there was one here in Oakville that you guys did a good white
Yep.
case study on.
Yep.
How important is that going to be with stores going forward into the future?
Yeah. Great question, because I've always been passionate about continuous commissioning. It's not just commission it and go away, because a lot have done that, and a lot of stores have done that, and maybe it's because they didn't have the controls in place in order to be able to continuously commission. With today's controls, and I've heard you talk about this many times, but CO2 system is all electronic controls, and now manufacturers have built in tools into our building automation system to be able to continuously monitor the condition of the system. And if a parameter is off, you know exactly who that user is that changed it. So you can go back and say, hey, why was this changed? Was there a real reason? Or go back and just have it automatically reset itself. To me, continuous commission is the key to optimizing energy performance 24/7. It really is. And if you compared it to the more mechanical systems of the past, yeah, maybe you couldn't have that same continuous commissioning. But today on CO2 system, with the sophistication of controls that are there, is activating that package is going to go a long way to not only making your system more efficient, but eliminating some of those transient conditions and alarms and refrigerant potential losses that can result by something being off.
And this is what I talk about with technicians, contractors, and even end users. I let them know, like, yes, this does cost. There's a fee to this.
Yeah,
It costs up front. But
yeah,
having someone go in there every week or every month is going to cost you a lot more money in the long run than having it
right,
done up front in the first place. And I know with the smaller retailer, it is difficult. They're just trying to keep the
right,
doors open and the lights on and regulations pushing them this way because there is a cost to it. And then there is some trial and error with that. Maybe that contractor in that area that has not done CO2 yet, so really
right.
though, you got to think about the bigger picture and maybe sometimes bite that bullet. Okay, let's even try it for 3 months or 6 months and see what it is compared to not doing it. And then look at your bill at that point.
Absolutely. Because there's two things. There's the annual energy, as we talked about, and then there's peak energy as well. So even if your system is not continuously commissioned and it starts to drift, the energy starts to drift, annualize, okay. But if it's drifting and now you're paying a peak demand charge and it's even higher than it otherwise should be if it was taken care of, you're gonna get hit again from a peak demand in the future. So obviously, those to me makes a whole lot of sense. Give you an example. I'm kind of working with a retail that's been just recently checked what it costs for a compressor contact failure. A lot of locations, and you wouldn't think, oh, compressor contact, a big deal, but on average, it's like $4,000 to $5,000. Something like that. That there's other things that you can do to improve the life of these things. You think about it, right? How often does the service tech change in contact? It's a small thing for maybe even a condensing unit can drive up costs, let alone, other things that can get away in a larger supermarket system.
I
Anyway,
agree
it's
with that.
interesting.
No, I agree with that because I've done trainings with technicians who came and talked to me and showed me, like, Trevor, I put these are the new contactors coming in on these units, and these are the ones that I go out and buy that's triple the price of what the manufacturer's putting on them, and they're lasting.
Right.
They're lasting
Right.
for 3 years. They're not
They're
failing
million
in 8 months.
cycles.
I'm like, okay, well, it's good. It's very important to do that. But if you're a
Yeah.
contractor out there and you're on like a plan with your customer, so compensation package, you got to pay for it. Like they give you a fee monthly or a yearly, and you got to
Yeah.
take care of everything at the store. You may want to invest in this for your customer because this might make you money. This is what you got to think a little bit differently. Well, why would I pay for optimization for my customer when they're paying me? They you know what I mean? So this is, I'm talking to some contractors that they're actually paying for their customers optimization, and they're making more money than getting all these calls because they have to pay for the blow offs and they have to pay for the gas and they have to pay for every roll, right?
Right. No, I've heard of some contractors actually doing the Connect Plus for themselves. So the enterprise monitoring, they're paying for the service so they can provide, to your point, better service to their customer and make money on these service contracts. Right. There's different ways of making money by keeping your customer system optimized at all times. If you can, that's great.
No, and it's the way you got to think a little bit differently. Yes, maybe it costs you money up front, but it maybe save you in the long run. And at the end of the day, you want to bring huge amount of value to your customer because they're going to keep coming back. And I know in supermarket, I keep hearing more and more. I work with a lot of contractors, like it's just so tight, you know what I mean? And the margins are so low, and it's highly skilled industry.
Yeah.
And which I really think refrigeration technicians, especially working on CO2, they need to get paid more. I'm advocating for it because I see some of the numbers HVAC technicians are getting paid, and it's almost the same as a CO2 technician. I scratch my head sometimes, but that's not my decision yet. But I'm going to help push that because these guys are highly skilled, like drives, digital, controls, like everything. And the guys going out there, they need to get paid. So we got a question here. Has Copeland or any manufacturer done an ROI study on continuous commissioning?
I would have to refer. I'm not aware of myself because I'm not on the control side of the business. I would have to reach out to my colleague, Jim Mitchell, to find that out. So I could get back to that individual, with that.
Yeah, no, and that's totally fair. I love this conversation because there's just so much to it. It's not just refrigeration anymore. It's this advanced technology that we're dealing with. What I love about refrigeration was getting boring. You know what I mean? TX valves, compressors, condensers, and I did supermarket because it was a little more fun. Now it's getting more exciting. There's all these technologies that are coming out. I'm learning so much about single and multi ejectors over the last couple of years. I'm excited when that gets here. Also, as energy recovery there, the PXG 1300. That's another one. I can't wait to go out and see a site with it on. Just these different technologies that are just changing the way it's been done, and especially the analytics. I really love the analytics.
Oh, the analytics stuff. Yeah, it's absolutely amazing. I've been involved in a few projects. The type of information you can pull out of hundreds of sites and have them in one easy to read table that you can compare site to site, things just pop out without you spending hours going through Excel reports. You're not going through an Excel report. You're looking at little charts and lines, and you can see the outliers very easily and focus on those. It's amazing. And you learn a tremendous amount.
No, I totally agree. And like I teach a lot of technicians, you got to start learning more about these trend graphs and understanding the percentage opens of valves, understanding how the case has been running this, because everything works in conjunction, as you know, because we can get into the operation side of CO2. Like we did the total cost of ownership. They get the installation because yes, this works. Say this booster system works in this area, and they get parallel compression. They got adiabatic cooling, whatever they have on it. But then there's that operation. So understanding that, the EEVs and all the cases work in conjunction with that flash gas bypass valve, with that high pressure valve, and when you see it all on a graph, it's so much to me as I continue to grow and learn. It's like, holy smokes. I used to just wing it a lot of times because I'd go out and get a pressure here, and then I run under the roof, get a pressure up there. Then I go to the rack room and get a pressure there. And then by that time, all the pressures have changed in the systems a bit. So it's like,
Yeah, exactly. So with the E3, you can take your graphs and have your high pressure valve graph on top, your bypass valve graph, your fan cycling, and your compressor cycling, have them all lined up one below the other, all with the same time scale, and you can just look at and see what's going on and see what effects one has on the other. It's pretty powerful.
yeah, and it makes a huge difference for a technician out there.
Right.
So you got to start learning. You got to get a I tell all the technicians in my course, you got to get your own computer for refrigeration. You see it in VRF world for years and years now. You know, those technicians having computers.
Right.
We need that stuff. And we're seeing more and more of that on our cell phones, that we can just have our cell phones and we're
Right.
commissioning things with our cell phone. Embrace these technologies because it's super exciting. Don't be scared of CO2. I've done over 80 podcasts on CO2. Talk to industry experts like Andre and many other ones around the world. This is happening. There's tens of thousands of CO2 systems out there, transcritical CO2s, millions of CO2 systems with millions, you know, from water heaters to industrial applications. And we're just going to see continue to grow.
No,
Any final thoughts, Andre, on system architecture and this transition that we're going to see over the next 5-10 years? Continue to see?
Yeah, I think what we're going to continue to see is an increase in condensing units, CO2 condensing units, because we haven't seen too much of those yet. That is something that really the OEMs have been developing. Right. And in 2024, because a lot of the regulations were lining up for 2024, 2025. And so that work has been started. Some have already been launched on condensing units. Others are planned for 2024. So that's one thing you're going to see a lot more about. You're going to see more, I would say, distributed CO2 systems with like the Transcritical Scroll, Copeland's Transcritical Scroll, small package, distributed equipment, adiabatic, non-adiabatic, with efficiencies like parallel compression. So you're going to start seeing more of that for sure. And we're also going to start seeing more high ambient strategies as part of that system. Because as we move these systems further and further south, that parallel compression you talked about, that's going to be more standard adiabatic gas cooling. Even though there's some maintenance involved with adiabatic, from a peak mitigation perspective, it really works well. Then from an annualization. And then some may decide to combine both parallel and adiabatic. Even though one, you may say, kind of mitigates the other to a certain point, but there's some value in having them both depending on where you are. And you mentioned these other strategies like the energy recovery, and you talked about ejectors, again, about high ambient mitigation strategies. And the other thing too, on the low side, these are all high side strategies. Yep. The low side, we're completing a low superheat study now. I'm just kind of going through the report on ultra low superheat. So what impact does, running instead of having 10 degrees superheat on those evaporators, unit coolers, let's float them, let's get them to zero. When we do that, the TD on that coil just has gone down. So my suction pressure rises, compression ratio on the rack decreases, and then there's an energy saving for that. So we're looking at that, and we're going to start seeing more of that application, because on the case controls, for example, we're designing case controls that can flip back and forth. So our CC200 can go from standard superheat to get it enabled to, okay, now I'm at zero superheat, and perform the function that that technology from that OEM requires. And then when you want to move back to normal superheat, so that's another thing that we're going to start seeing more of, for sure.
Yeah. No, I'm excited about that. There's one thing that I want to ask you though, and I've talked to you about this for years and years, is where are you guys with the transcritical booster scroll, the transcritical scroll? Because I was out in the UK in September at an event at Copeland. They had a bunch of units there. They're building their own unit out in the UK, condensing unit. Where are we at in North America right now with that?
Right now it's motor development, because the original compressors were developed with a 400 volt, 50 hertz motor. It doesn't work here. So we need 208, 230, right? three-phase, we need 460, we need 575 for Canada, and we need 380, 60 hertz for Latin America, for Brazil. So that's what's been delaying it here. So prior to those motors, now those motors are the 208s out to be in 2024, the 460 and 208 motors will be out. So prior to that, though, we're working with OEMs in order for them to understand the technology, apply it with the existing motor, and when the right voltage motors are out, boom, we'll have it ready for distributed racks and condensing units in two type of formats. What we call is an economized VI, which is the Transcritical Scroll has an economized port in it that digests flash gas from the flash tank, right? So instead of using a parallel compressor, you're using that economized port. And if anybody out there is familiar with our economized scrolls on HFCs, similar concept, right? You're 2/3 into the compression cycle, we dump this gas, and we can manage it more efficiently. So that's one way. And then the other one is what we call flash tank VI, which literally the flash tank can move up and down to improve efficiency. So on hot summer days, you can actually float your flash tank up. When you do that, you're not bypassing as much to the low side. And that injection port is digesting that flash gas up to, in the 750 to 800 PSI range. Another way of using the economized feature into the side of the scroll, for example. So that's coming in 2024. But we're excited about that. And
I'm excited, but I can't wait to see some of those
yeah.
out there. I've seen some already. It's going to be nice to see more and more, because that's how it's going to develop, going to get better too. Because as more of them get out there, you're going to say, okay, well, maybe we can add this, maybe we can change this, maybe we can do that, and then the efficiency and the options are going to grow for them. That's what's going to happen. It's just going to options.
I can just share this one quick slide. It just kind of just shows visually the options here. Let me just, so here's what I'm talking about. So today the centralized racks are on the left, but what's going to happen in the future, you've got more independent system solutions with transcritical scrolls, with a smaller compact system. And then, as I mentioned, as we move down to the right here, you've got the economized DVI, dynamic vapor injection, from a condenser unit perspective. And you mentioned that we've got them in Europe, manufacturers. We are not going to be selling this condensing unit in North America. Copeland's not. That's exclusive for Europe and other parts of the world. So we're working with our own OEMs to develop their own solutions with the Transcritical Scroll. So that's our strategy here in North America. So we're pretty excited about that.
Awesome. I'm excited. Like I said, I'm excited. Andre, any final thoughts before I let you go? Because I'm going to grab you again. You're just such a wealth of knowledge and just awesome dude. I appreciate you taking the time to come here and chat with me again. Any final thoughts for people out there listening?
No, well, I guess the final thoughts are just keep learning as much as you can. CO2 is a lot of fun. I mean, and you can make it a lot of fun because you never stop learning, right? And keep attending these sessions that you're putting on, doing a great job, and try to learn wherever you can and have fun at it. I guess that's really what I'd like to pass on.
Awesome. I appreciate that. How can people get a hold of you or get a hold of Copeland?
Yeah, you can get a hold of me at my first name. You can see up there, andre.patnode@copeland.com. And if you're looking for all kinds of information related to CO2, just go to E360 Resource Hub and then click on CO2 and boom, you get white papers, you get videos, you get articles, you get infographics, you get all kinds of cool stuff. So yeah. And coming up, I do have a 12-part CO2 blog. I don't know if you remember when I did them back in 2015. We're refreshing them all, making more current. So they'll start being launched December through April. So 12 blog series on CO2 coming up. So
I'm excited for it. I'm going to check them out for sure. I'm going to put that information in the description. So check it out. Andre, once again, thank you so much for hanging out with me at the Refrigeration Mentor podcast, and we'll see you at the next one.
Always a pleasure. Thanks, Trevor.